We are group 11 and we are going to present about deadlock, Banker's algorithm and safety algorithm. Our group member have Ng Hui Yuan, Xian Wenqi, which is me, and Tam Kai Li and Yap Ji Yun.
Good evening, my name is Tam Kai Li, and the topic our group choose, which is deadlock. Today, me and Wenqi will explain about Banker algorithm and safety algorithm. The question is considering a system with 5 processors, which are P0, P1, P2, P3, and P4. And there are 3 resources of type, which are R1, R2, and R3. The following table indicates the maximum requirement and current allocation for this solution. And the first question, determine the total instance for each resources. You can get the total instance with plus all the allocation in R1, also plus the available in R1. For example, the total instance for R1 is plus the allocation in R1, which are 3 plus 2 plus 1 plus 0 plus 1, we get 7. And after that, we use the value of 7 plus again with available in R1, which is 3. So we can get the total instance of R1 is 10. And the total instance for R2 and R3 we use the same way. So we can get the total instance for R2 is 7 and total instance for R3 is 4. The second question is determine the need matrix for the system. We can get the need value with use the max value minus the allocation value. For example, we can find the R1 of P0 with use the max, which is 8 minus the allocation, which is 3. So we can get the need is 5. And we can get the need for R2, which is 3 minus 1, we can get 2. And the R3, which is 2 minus 0 is 2. So we use the same way for all the need. Here we can get 5 minus 2, which is 3. And 3 minus 0, which is 3. And 2 minus 1, which is 1. And down here is 3, 0, 1. And here is 1, 1, and 1. And the last for P4, we can get 2, 2, 2. So this is the way to find the need. The third question is determine whether the system is in a safe condition or not. Now we need to find the safety algorithm to check if the need is smaller or equal with the available. For example, we use the need of P0, which are 5, 2, 2, and check it is smaller or equal with the available or not. The available is 3, 1, and 2. So we can get that the 5 is not smaller than 3, so this is false. If this is false, we can check the second one. So now we check the need of P1, which is 3, 3, 1. And now we want to check it is bigger and equal with 3, 1, 2 or not. So we can see that the 3 is not smaller than 1, so this also false. And after that, we check the need of P2, which are 3, 0, 1, and the available, which are 3, 1, 2. We can see that the need of P2 is smaller equal with the available, so this is true. Now we need to update the available. The original available is 3, 1, 2. And now we want to plus the allocation from P2, which is 1, 2, 0. Now we can get the new available are 4, 3, 2. And we continue check with the need of P3. P3 is 1, 1, 1. And we want to check with the new available, which are 4, 3, 2. So we can see that the need of P3 is smaller equal with the new available. So this also true. And because it is true, so we need to update our available, which is 4, 3, 2 plus the allocation of P3, which is 0, 1, 0. So we can get the new available is 4, 4, 2. Now we need to check the need for P4, which is 2, 2, 2. Is smaller and equal with the new allocation, which are 4, 4, 2 or not. We can see that the need of P4 is smaller and equal with the new available, so this also true. So now we want to update our available. The available is use 4, 4, 2 plus the allocation of P4, which is 1, 2, 1, so we can get 5, 6, 3. Now after finish the P4, we want to go back to see P0 and P1 is smaller and equal with the new available or not. The need of P0 is 522, and now we need to check with the new available, which is 563. Now the need of P0 is smaller and equal with the available, so it is true. And now we need to update the available. Now we use the available 563 plus the allocation for P0, which is 310. We can get the new available, which are 873. Now we need to check the need of P1 with the new available, which is 331, with the new available, which is 873. We can see that it's also the true. So now we want to update our available, which are 873 plus 201. So we can get 1074. We can see that the total available will equal with the total instance, which is 1074. So now we can get the safe sequence, which are P2, P3, P4, P0, and P1. And the conclusion is the system is a safe state and deadlock can be avoided.
Fourth question, can request 411 from P0 be granted? Provide a reason. Step 1, we have to check request P0 is less or equal with need. Our need is 522, which is true. Step 2, we have to check request P0 is less or equal with available. Request 411 and our available is 312, which is false. Conclusion, the request 411 from P0 cannot be granted because there are no resource available. The fifth question, if P4 requests for another instance 210, can this request be granted? Justify your answer. Step 1. P4 equal to 210 plus allocation 121 will become 331. Our new allocation 331. If P4 requests for another instance 210, can this request be granted? Justify your answer. Our new need P4 is equal with 222 minus 210 equal with 012, or P4 equal with 343 minus with 331 equal with 012 also. Our new need must be 0, 1, and 2. If P4 requests for another instance 210, can this request be granted? Justify your answer. New available 312 minus with 210 equal with 102. Our new available R1 is 1, R2 is 0, and R3 is 2. If new need is less or equal with new available, P0 is 522 less than and equal with 102. It's false. P1 331 less or equal with 102. Is false too. P2 301 is less and equal with 102. Is also false. P3 111 less and equal with 102. The answer is also false. P4 012 is less and equal with 102. It is also false. Conclusion, additional request 210 from P4 cannot be granted because none of the processes can execute. This is due to the system cannot provide a safe sequence and it will lead to a deadlock. This is all of our presentation. Thank you.